Okay guys, so I'm going to show you how to do a couple of problems on here, and then your assignment, I told the sub, will be numbers 1 through 4 and then 7 through 22. Okay? So the first two are just writing it in component form. I talked about in the exploration video how you do x2 minus x1, comma y2 minus y1, and you put the little sort of arrow parenthesis deals. So if you look at this point right here, if this is our x and y axis, this would be 4, 0, and this would be 0, 2. So when you use component form. Okay, so I started making this video and forgot to push record, so I've already started talking about it. So up at the top it gives you your assignment, and then in the first two we're just doing component form. So think of it as an x and y axis. This is 0, 2, and 4, 0. And so when I subtract those, this is my starting point right here. And this is my starting point, I know, because of the arrow. Okay, so it would be, I take my second minus my first, and that would give me a negative 4. And then my second minus my first, which would give me a positive 2. Oop. So what I want to point out, now that we did it mathematically, the technical way, you can also just look at it and say, okay, if I'm starting here, component form is going to be a negative 4 and a positive 2. Okay, so using that idea over here on number 2, I'm going a positive direction, and how many units am I going? I'm going a positive 4, and I'm going up a positive 1, right? So component form is going to be 4, 1. Okay, looking at 3 and 4, you have to sketch u plus v, vector u plus vector v, vector u minus vector v, and 2 times the vector u. Okay, so in order to do that, there's a couple ways you can do it. I need you to think of like vector u in component form, which would be 1, 1. And vector v in component form, which would be negative 1, 2. I just did it the way I did number 2. Okay, so I'm going to take those two vectors and I'm now going to add them together. So when I add them together, I get 0. So I'm just going to write it up here. I get 0, 3, right? So this is my u plus v. So I'm going to go over here, and I need to start wherever the other vector started and go 0, 3. So 0 and then 1, 2, 3 right here. So this vector represents u plus v. Okay? And then sometimes, like I said before, people do some dash lines there. Okay, same thing, I'm going to do u minus v. Okay, so I'm taking, add a color. Okay, I'll add green. Okay, so I'm going to take u, which is right here, and I'm going to subtract v. So 0 minus a negative 1 would be 2. So this is 2. And then I'm taking 1 minus 2, which is negative 1. Right? So this, now, I meant to switch colors, sorry. So you could see what I was doing. Okay, so from here, this is my starting point, I'm going 2 down 1. So over here is my vector u minus vector v. Okay, lastly, I take my 2 times u, so I'm going to u, and I'm doing 2 times 1, 2 times 1. So this is my new vector. I start here, so I go positive 2, positive 2. And this vector is 2u. Okay? I'm going to let you do 4. I am going to move on to the next page and talk about starting with number 7, where we really start talking about magnitude and direction. Magnitude and direction. And I'm just going to refer back to that link I sent you last night. So we think of a vector. I'm going to just dash a line here. This is the direction. So now we're putting some trig into it. Direction. And then this is my magnitude. Okay, so like for number 7, it gives us a magnitude of 6 and a direction of 45 degrees, right? So I'm going to write this in component form, which we know looks like this. So I take my magnitude and I multiply that by the cosine of my direction. Okay, so this becomes 6 times the cosine of 45. Why am I using cosine? Because this is the x location in my component form. So for my y, I will do 6 times the sine of 45. Okay, so that's going to be component form of magnitude and direction. And then I know what the cosine of 45 degrees is. I know that that's root 2 over 2, remembering my unit circle. So I get 6 times root 2 over 2. This simplifies to 3, so I get 3 root 2. In this case, because sine of 45 is the same thing, square root of 2 over 2, I get the same thing. So my final component form of a magnitude of 6 and direction of 45 degrees is 3 root 2, comma 3 root 2. Okay, so a little bit of unit circle usage again. Same process for each of the others. If I did number 8 with a magnitude of 10 and direction of 120 degrees, I'm going to set it up, take my magnitude and multiply it by my direction, 120 degrees. And same thing here for my y value. Okay. And then I would remember, think back to my unit circle or bust it out and remind myself that that's 2 pi over 3. So I get 2 times 2 pi over 3. And I would simplify. Did I say that? No. Oh, undo. Sorry. That was dumb. 120 degrees is 2 pi. I did not write the cosine. I wrote the angle. So the cosine is negative 1/2. So it'd be 10 times root 3 over 2 here, because the sine is of 120 degrees, root 3 over 2. Sorry, y'all. Brain fart. So my component form would be negative 5 root 3. Okay, you should be able to do the rest of those, 9 and 10. And then you are finding the norm or the magnitude. Okay, so just real quickly, like on number 11, so now we're working backwards. We're given component form 0, 4. In order to find the magnitude of this particular vector, also called the norm, we do the square root of our component form squared and adding that together. Okay, so we end up with the square root of 16, which is 4. That's our magnitude. And then in order to find our direction, so direction we are taking, we know Sorry, the direction, we're going to use the tangent. So we're going to say the tangent of theta is your y over your x, 4 over 0, which is undefined. Okay, and what angle is the tangent undefined? That is at 90 degrees. Okay, so this would be my direction, and that would be my magnitude. If you come across one that is not on the unit circle, then you would simply use the inverse tan in your calculator. Like we would push the tangent of -1 is 4 divided by 0. And that will give us 90 degrees, as long as your calculator is in degrees. If it's in radians, it's going to give you a decimal. So we're going to go ahead and make these in degrees. Okay, give those a shot. I'll answer questions next time. Bye.